Hello, let's continue our Sudoku adventure with Triple Double by MicroStudy. So we have normal 6x6 Sudoku rules, so in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. Additionally, we have clones in the grid. So these are the cages that are marked with letters here. So for example, this A and this A, what that means is that they have the exact same digits in them in the same relative location. So if I put a 2 here, I need to put a 2 here. If I put a 4 here, I need to put a 4 here, right? You can sort of see how they have the same shape. And so there's a similar relative location to here. What I can't do is like put a 3 here and a 5 here. And I also can't do like this. I can't do 2, 5, 4, and 2, 4, 5 and 2, 5, 4, because even though it's the same digits in them, they're not in the same relative location. So that's clones. They're exact clones. And so we have the A cage, we have the B cage, and we have the C cage. All right. We also have XV. So these two digits sum to 10. These two digits sum to 5. That's the Roman numeral for 5 and 10. And we have crop key dots. So these two digits are consecutive. And these two digits have a 1 to 2 ratio, which another way to put that is one is exactly double the other. All right, so those are the rules. I'm sorry for the extra constraints in there. We try to keep the number of constraints down so the rules are easy to read and understand. But hopefully these are constraints that you have encountered before and are natural to you. But we are going to try to keep the number of constraints down. And either way, I hope you enjoyed the puzzle. There's a link in the description for you to try it yourself. And I am going to get started right now. All right, so this being adding to 5 means they have to be from 1, 2, 3, 4, and we can immediately mark this as 1, 2, 3, 4 as well, because it's in the clone. They're clones. For a black dot, it can be 1, 2, it could be 2, 4, or it can be 3, 6. So basically there's no 5. So I'm not sure that's worth marking, but we'll keep that in mind. So there's no 5 here either. The X has to be 4, 6. There's no other option. So this B here has a clone here that's also 4, 6, and these are the same digit. So this 4, 6 pair sees this cell, which sees this cell. So this can't be 4 or 6. So it's from 1, 2, 3, 5. This also sees a 4, 6, so it's from 1, 2, 3, 5. I mean, the whole box is, but I'm trying to get the clones marked up so we can see how they interact with each other. Okay, we know these add to 5, so this can't be a 1, because if this was a 1, we'd have 1, 2. That would take 1, 2 out of here, and these needed to add to 5, right? Because they're the same as this adding to 5. And 3, 4 does not add to 5, right? So it can't be a 1. It could be a 2, but it would have to be 2, 3. That leaves 1, 4 for here. It can be a 3 if it was 3, 2. And if it was a 4, it couldn't be 4, 3. It would have to be 4, 5. But I don't think that's enough to really go on. I'm clearly missing something important about what's going on here. Okay, maybe this 4, 6, maybe it's the roping, right? We need 4, 6 up here somewhere. So there is a 4 and a 6 up here. Now we know they're not both here. If they were both here, that wouldn't have a 1 to 2 ratio. So this one is one of the 4, 6s, and then the other 4, 6 goes here. So it's either going to be a 4 with a 1, 2, or sorry, 4 with a 2. Sorry, not 4 with a 1, 2. It's either a 4 with a 2. I'm used to 4 having 2 different digits, but 8 doesn't exist in 6x6. So it's either 4 with a 2 or 6 with a 3. So we can put that C, we can transpose over here to be 2, 3, 4, 6. I will say that whatever this digit ends up being, this is interesting, actually. Whatever this digit ends up being, it can't go here, which is also here. So we need this digit to be up here, but it's not here. Similarly, we need this digit, which is the same digit. Wow. Okay, yeah, I got it. This digit is the same as this digit. I'm going to use a single color here. So green. We're asking where green goes in this box. Well, it sees down and it sees over. And we know that both of these are the same digit. But it also sees this cell here, which is the same as this cell. So if we look at what can't be green, none of these can be green. So this is the green 4, 6. Okay. Which means this goes here. Now, green does need to go in this box. It's going to be in one of these two cells. If it went here, if this was green, it would also go here. Excuse me. Oh, wait, hold on. I got something easier now. Now that I'm looking at the clones. These two greens look down. Where does green go in this box? It goes in one of these two. But it can't actually go in the bottom one because the bottom one's cloned here and that sees a green. So this is the only place for green in this box, which is then transposed here. And remember we said 4 could not go with 3, because if 4 went with 3, then this would not be able to add to 5. And it needs to because it's cloned here. So this is a 5, which takes 5 out of all of these cells. It takes 5 out of here as well, because that's a clone. Okay. Do I need to think about this one, this other 4, 6? We know that 5 is in one of these two. We can mark that. Which means 5 goes down here. Can 5 be here? I don't see why not. Okay. Oh no, it can't be. Right, of course. 5 can't be here because there is a 5 in the column. So 5 is in one of these two. Is there any reason to think that 2, 4 or 3, 6 doesn't work? That's also here. Okay. We should be able to place the final green. It goes here. But it's not super helpful, I don't think. This final C, I haven't marked it up. So what can it actually be? I think it can be anything. Well, it can't be 4 or 6, because it sees a 4, 6 pair, and it can't be 5. So it's only from 1, 2, 3. Because it sees 4, 5, 6 in some way. So this 4, 6 goes here. It goes... Oh, right. Okay, so where does this 4, 6 go in this box? That's what I'm seeing. This 4, 6 isn't here. It's not 5. And it's not green. Specifically, it's not green. And so it goes here, but these can only be 4. So it has to be a 4. So we have a 4 here, and that's this 4. And then all the greens are 6s. Very nice. That lets us clean this up quite a bit. And we know because there's a 4 here, there must also be a 4 here. So it can't be a 4 elsewhere in the box. Now that there's a 4 here, there must be a 4 down here. That makes it a 1, 4, because it has to add to 5. So that 1, 4 pair takes 1 out of here, which is B, so that's here. This is 2 or 3. That makes a 2, 3 pair. So this is not, this could be a 1, but it's not 2, 3, 4, or 6. So it could be 1 or 5 only. Same here. This can be a 1, but it can't be 2, 3, 4, or 6. So it's also 5. So yeah, I guess for the column, it's just a 1, 5 pair. Should have seen that, but whatever. Okay, I can get rid of green now because we know it's 6, so we don't need that. So we know these are the same digit. Does that help us in any way? We know these are the same digit. So let's turn green into this one now. So green doesn't go here or here. So green goes in one of these two. This one would end up here though. Ah, yeah, so we have the same thing with this cell. So it can't go here, it can't go here, but it also can't go here because it can't go here. So it is not here. So this is a 1, 2, 3 green. And importantly, it means it's not 5. So now 5 in this box can only go where our remaining corner mark is, which is here. Okay. And now the green, they look down, can only go here because we know it's not 6. And so that makes it a 1. So these are all 1s. That makes these a 4. This is a clone 1 as well. Okay, and now it looks like we are doing quite well. This is going to be the 4 for the box. Let's clean this up a bit. This C is here. Ah, this 2, 3. Okay, yeah, we can place the 4. 4 goes with 2 because it's on a black dot. These are 3s. That's a 2. All right, I can get rid of the color now. And let's finish this up. So we need a 3 here, 5 here, 2 here, 3 here, 5. Okay, this box needs a 2, which goes somewhere here. It needs a 3, which joins the 2 here. Oh, we have a clone here, so let's do that. 5. It's a 2 here. Okay, so that's 2 and 3. That's 3 and 2. And then here we need 4 and 5, which go like that, and we're done. All right. It took me some time, but I was taking my time there. So hopefully you didn't struggle too much with this one. It was a little bit complex, but some targeted coloring definitely got the job done. So let me know how you felt about the difficulty of this puzzle. And of course, if you enjoyed this puzzle, then why not leave a like, subscribe, and a kind comment below.